Hi, welcome to Madcom. In this particular video, we will be discussing another important question from NCERT Chemistry Class Plus 2, Alcohol, Phenol and Ether. So in this particular question, the question is, the following is not an appropriate reaction for the preparation of tertiary butyl ethyl ether. What would be the major product of this reaction? Write a suitable reaction for the preparation of tertiary butyl ethyl ether. It's better you people to watch the previous videos where we are explaining about the mechanism of formation of ether by bimolecular dehydration reaction, that is acid catalyzed dehydration reaction. If you watch those two videos, you can understand the mechanism of the acid catalyzed elimination reaction as well as acid catalyzed substitution reaction in order to form the formation of ether. I will give you the link for that particular video in the description box. Please check out that particular video first, then watch it. Or if you're having a very good basic understanding about the concepts, you can understand from this video itself. So when you're looking at this particular reactant, our reactant has C2H5 O minus Na plus, that means an ethoxide molecule is allowed to react with an alkyl halide. When you're having an alkoxide molecule or an ethoxide molecule, it can act as two different type of actions can be there. It can act as a base or it can act as a nucleophile. If it is acting as a base, it will try to abstract proton. If it is acting as a nucleophile, it can do substitution reaction. To form a nucleophilic substituted product. If it is subtracting the product, it will be leading for the elimination reaction. So depending upon how this particular ethoxide ion is acting, whether it is acting as a base or whether it is acting as a nucleophile, the product would varies. So if you are considering our reactant, that is C2H5 O minus Na plus, when it is allowed to react with the tertiary butyl chloride, you're allowed to react with the tertiary butyl chloride. Assume that this particular alkoxide molecule, ethoxide molecule is acting as a base, acting as a nucleophile such that it can go nucleophilic attack. The nucleophilic attack on this particular electrophilic carbon. Why this carbon is electrophilic? Because it is attached to an electronegative chlorine atom. Due to the presence of an electronegative chlorine atom, there will be a partial positive charge in this particular carbon. Due to that, this particular nucleophile can easily attack here. So if the nucleophile is coming and attacking this particular carbon, this particular bond can cleave. That means it will be following substitution nucleophilic bimolecular mechanism. But when you're considering this particular carbon is surrounded by three bulky alkyl groups or three bulky methyl group. These three bulky methyl group will be offering a very big steric hindrance. Since it is offering a very big steric hindrance such that due to the steric factor, this particular nucleophile cannot easily come and attack this particular carbon, or it cannot undergo nucleophilic substitution reaction. So the possibility which is going to happen is when you are having this particular C2OH minus, when it is acting as a base means, when you are considering this particular middle carbon, the middle carbon is called alpha carbon because the halogen is attached to that particular carbon. This particular carbon will be called as beta carbon. The hydrogen which is attached to that particular carbon can be called as beta hydrogen. So what can happen? This particular ethoxide molecule can pick this particular proton such that this bond will get shifted and chlorine will cleave. As a result of this, HCl will leave. That means it is undergoing a dehydrohalogenation reaction or an elimination reaction. That is nothing but elimination reaction. So you will be getting CH2 double bond C, CH3. So you will be getting an alkene molecule. So what is the major product we will be obtaining over there? The major product you will be obtaining will be an 2-methyl. You will be obtaining 2-methyl prop-1-ene. 2-methyl prop-1-ene. if you want to obtain tertiary butyl ethyl ether, if you want to obtain tertiary butyl ethyl ether, so you want CH3, CCH3, CH3, O C2H5. So now we came to understand that if the reaction has to happen means the electrophilic sender should not be steric hindered. That means this particular alkoxide molecule should be acting as a nucleophile. So our nucleophile should be CH3, C, CH3, CH3, O, Na plus, O minus, Na plus, is allowed to react with CH3, CH, CH, Cl. So this will be the electrophilic carbon. If it is electrophilic carbon, this particular bond can come and interact here. When it is allowed to interact here, or they are undergoing nucleophilic substitution such that this bond will cleave and you will be getting CH3, C, H, H, O, C, CH3, CH3, CH3. That means tertiary butyl ethyl ether will be obtained. So whenever a question is asked like this, so what do you want to think? For example, if you're having an alkoxide molecule, this alkoxide molecule can act as both a nucleophile as well as a base. When it is acting as a nucleophile, if that particular alkyl halide, corresponding alkyl halide is less steric hindered, means it will be following, or it will be favoring the nucleophilic substitution reaction. Other way, there will be undergoing elimination reaction to obtain an alkene or alkyl. Okay, fine. So hope the explanation is clear. If you want any further clarification, do let me know in the comment section. When you are having the time, please check our channel. There are various playlists are available relating with the physics, chemistry, mathematics of class 10, plus 1, plus 2, as well as higher topics are also being discussed. Please cross check. Please share with your friends, family members, teachers, and everyone. As a token of gratitude, please like to this particular video, subscribe to our channel, keep watching, keep learning. Thanks for watching. Bye.